Hi all, Brian O'Connor here. So we're having a look at another bite size. This bite size we're going to look at layer 1, the physical layer of the OSI 7-layer network model. One of my previous bite size videos we had a look at exactly what the OSI 7-layer model was. In this little bite size session we're going to look at what is the physical layer, and we're also going to have a look at what devices live at the physical layer. So again, if anybody's doing any exams on networking, you're going to be asked questions about this. It's also quite useful to know what the different layers do, as it will help you to troubleshoot any network issues that you may have within your organizations or even at home. So we're going to start off by having a look at what is the physical layer. So the physical layer is layer 1 of the 7-layer network model, and it is responsible for things that we can see physically. Name's a bit of a giveaway in the case of the physical layer. The physical layer itself is a physical component. So what we have is we can physically see the links between devices. If we're looking at wireless, yes, you may not be able to see wireless transmissions, but you can see physical cables. And the link that we have between the network nodes is created by using some form of transmission or physical media. Now that could be cable, like we said, it could be wireless. And the physical layer of the OSI layer is responsible for the transmission and receipt of bits from one node to another. At the physical layer, a segment, which is what we connect our devices to, can be seen as really a single piece of cable. We sometimes call that a broadcast or a collision domain. And a network overall is typically divided into segments to cope for physical restrictions on the network media, and this will allow us to improve performance. It'll also allow us to improve security as well. So the physical layer actually specifies a few things. One of the things it specifies is the physical topology, so the cables, what we can physically see that we physically connect our devices to. So this is the layout of the nodes and links that we use and establish by the transmission media. What we also have at the physical layer is we also have the physical interfaces. So the physical interfaces specify like mechanical specifications for network mediums. So for example, if we have twisted pair cable, we may be using unshielded twisted pair cable, we may be using shielded twisted pair cable, we may be using fiber optic cable, we may be using wireless, and the physical interface specifies the specifications that we need for that medium to work. Other things that are specified at the physical interface is the connectors that we use on our network device. So if you look at a standard network device that we may have on our work network, or we may have physically wired at home, we'll be using a thing called an RJ45 connector. And the RJ45 connector, if every network card manufacturer uses the same network adapter type, that means that we get the flexibility to choose what is best for us in our networks. Also at the physical layer, we also specify how the data is transmitted and received over the physical medium. So what we're doing at this point here is we're specifying things like modulation schemes, so how we generate the ones and zeros, how we time those ones and zeros going across the wire, and how devices at both ends synchronize the data. We don't want one device to start talking when the other device isn't ready to receive. And finally what we have is what we have in the case of devices used at the physical layer. So one of the devices we use at the physical layer is we use a device called a transceiver, and the transceiver, as its name may imply, this is the part of the network interface that is responsible for sending and receiving the signals over the network media. We also have repeaters, and repeaters are devices that take the signal, amplify the signal, and this allows us to extend the maximum allowable distance for a media type. So for example, unshielded twisted pair has a maximum of 100 meters. If we have two devices that wish to communicate with each other, if we put a repeater in the middle, that then extends that different distance up to 200 meters. What we also have at the physical layers, we also have hubs, and a hub is a multi-port repeater. So a hub could be an 8-port, 16-port, 24-port and so on, that will allow us to connect multiple devices together, and the hub becomes the central point to give us our hub-spoke network. So between any two devices with unshielded twisted pair cable, we can have a maximum of 200 meters distance between those two devices, but we can have more devices than the traditional repeater. Also at the physical layer we have media converters, and the purpose of a media converter is to convert one media signaling type to another media signaling type. So this gives us more flexibility within our network to the types of devices we can connect. And me approaching 50 years old, I remember these fondly, but we have modems. And modems, it stands for modulate and demodulate. And this is a device that converts the digital signal that our computers communicate with into an analog signal that we use on our public switch telephone networks in the past. And that's the end of this little bite-sized session about Layer 1. I will be producing more. I hope you find them useful. And if you have been watching them, thank you for watching them. Speak to you in a later demonstration video or a later bite-sized video. Thank you.